The AI-powered robots unlocking self-replicating intelligent machines. Introduction. Artificial intelligence, AI, has revolutionized numerous industries, but its potential reaches even further. Imagine a future where AI-powered robots possess the capability to not only build other robots, but also create increasingly intelligent iterations of themselves. This concept, known as self-replicating intelligent machines, represents a significant milestone in the field of robotics. In this article, we explore the exciting prospects, implications, and challenges surrounding the development of AI-powered robots capable of building and advancing their own kind. The concept of self-replicating intelligent machines. The idea of self-replicating machines stems from the desire to create autonomous systems that can reproduce and improve upon themselves. Inspired by nature's ability to evolve and adapt, scientists and engineers have long pursued the goal of designing machines capable of self-replication. With advancements in AI, this vision is now becoming a tangible possibility. AI-powered robots as builders. Current generation robots are already employed in various industrial processes, such as manufacturing and assembly. However, their abilities are often limited to pre-programmed tasks within well-defined parameters. By integrating AI capabilities into robots, we can empower them to learn, adapt, and make informed decisions during the construction process. Achieving self-replication. To achieve self-replication, robots must possess the ability to create copies of themselves, including all the necessary components and assembly mechanisms. This involves not only physical construction, but also the ability to replicate the underlying AI algorithms and software architecture. Benefits of self-replicating intelligent machines. Rapid scaling. Self-replicating robots could exponentially increase their numbers, allowing for rapid scalability in various industries. This would lead to enhanced productivity and reduced production costs. Increased efficiency. By building robots capable of improving upon their own design, we can achieve higher levels of efficiency and performance in subsequent iterations. This iterative process of improvement would result in machines that outperform their predecessors. Resilience and redundancy. Self-replicating systems can ensure redundancy and resilience in critical tasks. If one robot fails, others can quickly replicate a replacement, minimizing downtime. Challenges and ethical considerations. Controlling reproduction. Implementing safeguards to control the replication process is essential to prevent uncontrolled proliferation or the creation of malicious entities. Ensuring safety. Self-replicating robots must be programmed to prioritize safety and adhere to ethical guidelines. They should possess mechanisms to avoid harmful actions or unintended consequences. Technological complexity. The development of self-replicating intelligent machines is an immensely complex task, requiring advancements in robotics, AI, and manufacturing technologies. Ethical implications. The advent of self-replicating robots raises ethical questions, such as the impact on employment, resource allocation, and potential unintended consequences. Conclusion. The prospect of AI-powered robots capable of building and advancing their own kind is both awe-inspiring and challenging. While self-replicating intelligent machines promise immense benefits, they also demand careful consideration of ethical implications and potential risks. By addressing these challenges responsibly, we can unlock the full potential of self-replication, revolutionize manufacturing and automation, and push the boundaries of AI and robotics towards a future where intelligent machines create and evolve alongside us.